Okay. So let's get started, everybody. You should have at the top of your paper 2-3B notes or 2-3B slope. We are going to talk about parallel and perpendicular lines. Okay. Parallel lines. Parallel lines never cross, and they have the same slope. So you want to say that they never cross. They have the same slope. So any two lines with the same slope will be parallel. So like y equals 2x minus 7 and y equals 2x plus 3. Those two lines are parallel. All vertical lines are parallel to each other. So x equals 2 is parallel to x equals 7. All horizontal lines are parallel to each other. So y equals 4 and y equals 6 will be horizontal lines that are parallel. So if they have the same slope, they will never cross and they will be parallel. Now you have to be concerned also that they aren't duplicates. So if this one says minus 7 and this one says minus 7, they're duplicate lines, so that doesn't count, okay? So they have to have different intercepts and the same slope. Now let's talk about perpendicular. Perpendicular are two lines that meet at a 90-degree angle. Okay, so they meet at a 90-degree angle. What do we know about their slopes? Their slopes are opposite signs and reciprocals. So I say opposite and reciprocals. So they would have to be opposite signs and reciprocals. So if we had that same line y equals 2x minus 7, it would be perpendicular with y equals negative 1/2 x plus 2. Okay. So again, why? Well, if the slopes match, they're following that same steepness, that same path, up 2/1 in this particular case. If they're perpendicular, we want them to meet perfectly at that 90-degree angle. So where this one goes up 1 and over 2, this one will go down 1 and over 2. And so then they'll meet up perfectly so that they create that 90-degree angle. Okay? So the way you can check is if they match, you can say they're parallel. If you multiply them and you get negative 1, you can say that they are perpendicular. Okay? So an example, I think it's 3, maybe because the other ones are, but we can call it. We can call it 2 and 1. Or 1 and 2, oh, goodness gracious. Okay. In this first example, we're checking to see are the lines parallel, perpendicular, or neither. Okay. So in the first example, the first one there, so we're checking are they parallel, perpendicular, or neither. In the first line, we know for sure that the slope is 2. So I'm going to say the first slope, and we can designate that with a little sub 1, m sub 1 is 2. Now the second slope is a little harder to determine just because of the way that it is written. So let's do a little rewrite on that second equation. So let's take the 2x, let's subtract it and put it to the other side. So it would be negative y equals negative 2x plus 3. And then I don't want a negative y for it to be in slope-intercept form, that y equals mx plus b. So if I divide off the negative, I get y equals 2x plus, or minus 3. Okay. So what's the slope of our second line? What's the slope of our second line? Somebody tell me? Yeah, so now that I've rearranged it, you can find that slope very quickly. Our slope is 2 again. What did we say we know about two lines that have the same slope? They're parallel, so you would write the word parallel. So you can't always just look at them and go, oh, yeah, those are parallel. You might have to do a little rearranging to find the slope of one and then compare them, okay? Do we have any questions about that example in example 1A? Okay, now let's do the same thing for example 1B. Now again, we can see that our slope for our first line is 2. So our first slope is 2. Let's do a little rearrange on this second one. So that one's, you just slide over that 2x, take it to the other side, it's negative 2x in one step. So we get y equals negative 2x plus 4. So our second slope is negative 2. So what I always ask myself when I'm doing a problem like this is, do they match? Are they perfect matches? No. So they're not parallel. Now, is one positive and one negative? Yes. So that's good. But if you multiply those, do you get negative 1? No. You get negative 4. So they have to be reciprocals of one another. One has to be positive and one has to be negative. Doesn't matter which. And so this is neither. Okay. It's not parallel, it's not perpendicular. They're going to cross somewhere. Who knows? I don't know. Okay. Let's do one more. Same thing. We know our first slope very nicely. Our first slope is 2 again. I didn't change that first one. But let's take a look at this one. Oh, it's the same equation. Let's make it, let's do a little switcheroo here. Let's make this equation, this front one, let's make it, yeah, I think that might work. Let's make it x plus 2y. So x plus 2y equals 3. Let's do that. X plus 2y equals 3. If you could write down your second equation as x plus 2y equals 3. Okay, so we already know the first one was 2. Now we do have to do some rearranging for this second one. So the first thing we want to do is let's take this positive x to the other side and make it a negative x. That's our first step. So we would have that 2y equals negative x plus 3. And we've done this many times now. If we want to get rid of that coefficient that's attached to the y, what do we got to do?
Divide.
You got to divide. So we're going to divide everything by 2. So I would just put a little over 2, over 2, over 2. And we get y equals negative 1/2 x plus 3/2. Now look at the way I wrote negative x over 2. I wrote it as negative 1/2 x. You don't have to. If you recognize that your fraction would have a negative 1 on top and a 2 on the bottom, go for it, okay? What is the slope we just found of our second line? Negative 1/2. Okay. Are they the same? No. So we know they're not parallel. Is one positive and one negative? Yes, so that's good. If you multiply them, do you get negative 1? Yeah, so that means they're opposite signs and reciprocals. 2 times negative 1/2 is negative 1. So they are perpendicular. Okay? So, it really just locating the slopes, the coefficient on your x once you've solved it for y. What are the slopes? If they match, they're parallel. If you multiply them and get negative 1, they're perpendicular. If neither of those things happen, they're just lines. Okay? Everybody good with that? Yes?
In the example at the start, the
Uh-huh.
lines thing, but y equals 2x minus 7 and y equals 1/2 x plus 2. But this is a positive 2 and a negative 1/2. Are they still perpendicular?
Yeah. So for perpendicular, they have to be different signs and reciprocals. So since one is positive 2 and one is, when we rearrange it, negative 1/2, positive 2 times negative 1/2 is negative 1. That's a good way to check. So are they reciprocals? And is one positive and one negative? You have to, if you multiply and get negative 1, that's the key to see if they're perpendicular or not, okay? Any other questions about our first example? Okay. Now, let's talk about the graphs for a minute. Let's prove that in example 1, the graphs are doing what we think. So on your paper, do you guys want some graph paper? You good with graph paper? You can just sketch it. It doesn't matter. But okay, so on the paper, the first line we have to graph from A is y equals 2x minus 5. And so I'll make that one, let's make that one blue, okay? So let's think about how we graph it. Start at -5. So your starting place is always your y-intercept. Count up 2 over 1, up 2 over 1. Now we want it to be very nice and straight as much as you can because we're comparing it with some other lines. Okay. Now in A, one of the lines that we were looking at is 2x minus 3 equals, I'm sorry, that is not what it says. It says 2x minus y equals 3. We rearranged it to be y equals 2x minus 3. Can somebody tell me, what's my starting place on the graph? Where should I start on that graph? -3. So we go to the y-intercept, the y-axis, we hit the point 0, -3. And then we have to count up 2 over 1, up 2 over 1, because we have a slope of 2. And indeed, when we graph them, you can tell that they are parallel like we expected. So they should look like little railroad tracks, and that's a good way to see that we are right. Now in B, we have already graphed y equals 2x minus 5. The other equation, 2x plus y equals 4. When we rearranged it, we got y equals -2x plus 4. Now we claimed that there's no good relationship between these two, so let's check the blue one and the green line. I'm going to go. What's our y-intercept or our starting place here? What's our starting place this time?
4.
Yeah, you're going to start at 4. Our slope is -2, so we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And you see how it's not like a 90-degree angle there? That it's kind of, sorry if I could let me, you know, this angle's a lot bigger, right there, that one. And our x is kind of skinnier. It's not a perfect 90-degree angle, okay? So it's neither, just like I thought. And then finally, let's do the last one. So in C, our rearranged equation was y equals -1/2 x plus 3/2. What's the decimal that we could use as our starting place for 3/2? 3/2 decimal, what is that? You could just put 3 divided by 2 in a calculator. Just 1.5. So we're going to start at 1.5 and just try to estimate that as best you can. And we're going to go down 1, just stick right in the middle again, and over 2. Down 1, over 2. And then when we make the line, we better hit it in a 90-degree angle like we expected. So let me kind of zoom in there a little bit. You can see that the red line hits the blue line and the purple. In geometry class, there was a theorem that it is if one line is perpendicular, or if two lines are parallel, if a line transversal is perpendicular to one, it's perpendicular to the other. So it's actually perpendicular to both the blue and the purple. But whatever. There is a theorem name for that. I don't know. I've never really taught geometry, so. So there's that. Everybody understand how we graph that? Okay. So now, let's look at example, I don't know, we'll call it example 3. Example 3 is kind of an interesting one. It says we have 2 points. One is 3r and one is 2, 4. And then we want to find the r that will make the slope 1/2. So we're looking for the r that will make the slope 1/2. So all we're going to do is use the equation for the slope. y2 minus y1 over x2 minus x1. Okay? So that's your slope formula that you have to have memorized. You got to know it by heart. It never goes away, even if you take college algebra or calculus. It's a formula forever. So let's take and label our points x1, y1, and x2, y2. Okay? And let's plop that into the slope formula. Okay? If we do that, we get 4 minus r on top. That's the difference of our y's. The difference of our x's is 2 minus 3. And what do we want that to be equal to? We want that to equal 1/2. So that's just the setup. One of them we can definitely simplify. 2 minus 3 is a number. So I'm going to write it over here to the side. 4 minus r over -1 equals 1/2. Now, that's a proportion, which you should have solved in probably pre-algebra and algebra 1. To solve a proportion, the best way to do it is to cross multiply. Now, to cross multiply that, the 1 is an algebraic expression. It has to be in parentheses, so that when we multiply by 2, we're going to use the distributive property. So that's what's important, okay? So let's cross multiply that, and let's watch what happens. 2 times 4 minus r. Feel free to write it out first, and then use the distributive property. But if you know the distributive property, you can just distribute by 2. -1 times 1/2 is -1. So we're just cross multiplying. That's what's great about a proportion. You guys sometimes mention with fractions a lot cross multiplying where it doesn't apply. Well, this is how it's going to apply. So we're going to get 8 minus 2r equals -1. And then it's just an equation. We know how to solve that equation. We've been practicing equations. We would subtract 8 from both sides. We get -2r equals -9. We're going to divide off that -2. And as long as it is reduced, I'm okay with an improper fraction. Dividing by 2 is nice. If you wanted to call that 4.5, you're correct. 9/2 is also correct. Does everybody see how we did that?
See the left side?
Huh?
Can I see like the whole thing?
Oh, yeah, definitely. Let me scooch out here. So we're going to find r to make the given slope of 1/2. Can you see it at that tiny, or do you want me to zoom in a little bit?
No, I see it.
Okay. I need to look at something real quick. Okay, there we're good. You good with that one? Anyone have any questions? Does that make sense how we got that r? Cross multiply, set up your slope equation, cross multiply, solve your equation. Okay. Now, for these last ones here, we have 4 lines we are going to graph. So if you're doing it on your paper, if you want to make 4 separate grids, I always have colored pencils over there if you want to make each line a different color, because otherwise it's hard for me to see what your lines are, but I usually will go with a different color. So we're going to graph each of these situations. So if it says in A that we're going to go through the point 2, 4 with a slope of 3, we always need a starting point. So go to the point 2, 4, which is 2 to the right and up 4. Put your point. If a slope is 3, that's really meaning 3 over 1. So we go right up 3 and right 1. Okay. So from that point, go up, count up 3 and over 1. Now, do you see how we're up in the top of my graph paper? We're up at the top of my graph paper. Colored pencils are in the pink buckets. Always. And there's highlighters and like little red ones. So highlighters, colored pencils, whatever. Okay. So if I see that I'm in that upper corner and I need to go down further, I sometimes will count down and to the left. 2 negatives is the same as going in a positive direction. So again, you guys already can tell, I am not the best at making a straight line. Thank God the iPad helps me. But there you go. Okay, so there's our first one. We have started at the point 2,4. We went up 3 over 1, up 3 over 1. We're good to go, okay? Everybody got our first equation on their paper. So start at the point 2,4, count up 3 over 1, up 3 over 1. And there you go. Okay, let's do it again. In B, we have a starting point at -1, 0. That is on the x-axis, that's the x-intercept for that line. Now this time, -1/2, you can either go down 1 and to the right 2, or you can go up 1 and to the left 2. That also works, okay? I'm going to go down 1 to the right 2. Down 1 to the right 2. But once you can see the path it's taken, you can go in the opposite direction too. That was bad. So that's what our second line looks like. Okay. Now, C and D are a little different. We are using the information from A and B to complete those. So first, let's look at C. If we're through the point 1, 1 and parallel to A, we get to use the slope of 3 again because parallel lines have the same slope. So that's really telling us that we're going to start at 1, 1 and that we're going to count up 3 and over 1. And I overlapped, I got the same line, which was not intentional, but kind of interesting. Okay. So if we're through the point 1, 1 and we have a slope of 3, you actually end up coloring, I colored over top of my blue line because they're identical lines. Mrs. Hott was doing good when she made this one, wasn't she? Let's look at D. If I'm through the origin, that is the point 0, 0. That language is a term you should know. Origin just means that center point, 0, 0. If I'm perpendicular to B, instead of -1/2, my slope, I have to change the sign. So instead of negative, I'm going to make it positive. And then flip it upside down. Take the reciprocal. So the reciprocal of 1/2 is 2 over 1. Now, normally I would say if the answer is 2 over 1, leaving it as 2 is okay. You know what I mean? But 2 over 1 is nice to keep it. So then you have a rise and a run. So you're going to start at 0, 0. We're going to count up 2 over 1. Up 2 over 1. We're going to make our line. We should see that it hits the first line, or the line, I did in green. It hits it in a 90-degree angle. You can see that's a 90-degree angle. Oop, I would say pick it up. Mess up the whole line. But you can see, if I can get it to move, that it does indeed hit our green line at a 90-degree angle like we wanted. Okay? So that is the only notes we're doing for today. Follow those notes and those examples as you go through your homework. That's why you take notes, so you have it like a little book to look at, a little reference sheet. And then you're going to be able to do this. Now, as far as these go, some of them are very repetitive. And if you've already started, I apologize because some of you jump in and you're so let's just do odds. Oh, I might give you some bonus points if you did it, but if you already went. Okay, let's do odds up to here, okay? I'm looking. Well, since these ones are you almost all done? These ones I want you to do all of those ones and all of those ones. So really, I took out 6 in the top there, okay? So odds
23 questions, guys.
and all,
And guess what? I
Okay.
didn't go one section.